Hey everyone, Jesse here from Fresh Spaces. I've been told by my team that I can talk forever and I can also nerd right out about building. So my challenge now is to make videos that are 4 minutes or less and try to explain something about what we do so that everyone can understand it. You guys ready? All right, this episode is about interior versus exterior insulation. So basically the job of insulation is to stop air movement and to keep our temperature constant inside while it fluctuates up and down outside. And there are two general approaches to insulation. The first approach is putting the insulation in the wall, in between the studs, packing it in there behind the sheathing. And the second, and the newer approach, is to put it on the outside of the sheathing and use a hydrophobic insulation. And there are a few different advantages to this, and we'll talk about those shortly. So our industry is slowly moving towards the exterior insulation, and it has to do with moisture and dew point primarily. Let me explain. I'm going to use an example with a home in our climate, which is a heating-dominated climate. So summer average highs are around 19 degrees, and then winter lows are around 0 degrees, and that's with the top and bottom 10% of those excluded in that line of best fit. So we can safely say that we heat our homes more than we cool them. So warm air, by nature, can carry much more moisture than cold air. And so when you have a home, and say the interior temperature is a nice modest 21 degrees, and it's something like 0 degrees outside, you're going to have a temperature gradient in the wall, and that looks like this. And in that temperature gradient, you're going to have a dew point, and I've drawn it right about here. Dew point is when the interior air that's nice and warm, carrying moisture, can't carry that moisture anymore. So basically, it has to lose it somewhere. So we're going to do some quick math here. 21 degree air at 40% humidity at 101 kilopascals, which is basically the sea level air pressure, that's going to carry about 6 grams of water per kilogram of air. The air outside, which is at 0 degrees and 100% humidity, so it's holding all the water that it can, is going to carry about 2 grams of air, 2 grams of water per kilo of air. And now in a building where there is air leakage, and there is always air leakage in a building, the air will tend to flow from warm to cold. And that air that transitions the insulated space will lose its moisture when it hits that dew point, so when the air can't carry any more moisture. That's when it turns from moisture in the air that just floats around into water droplets. And it tends to turn into water droplets inside your wall if you have an interior insulated wall. So you can see why water in your wall is not a good thing. Well, the insulation itself may be waterproof, but the wood studs, the plywood, the drywall, etc. isn't waterproof, and that's a potential rot problem. So if we go to our second way of doing things, and we place all the insulation on the outside of the wood areas and doing our Tyvek or our other water-resistant barrier on the sheathing like normal, but inside the insulation, we're going to see the temperature gradient drawn something like this. So it's all constant here, then it drops through the insulation on the outside of the wall. So basically, the dew point stays the same in regards to the insulation, but now it's outside all of the wood. And so just like all that old furniture in the museums, that 800-year-old furniture that has never gotten moisture, has never been wetted and dried, this wood has no reason to rot. It can theoretically last forever. So you got a 500-year-old house and you got a 50-year-old house, and they're probably going to show about the same amount of rot on the inside. So there are costs and challenges associated with the newer approach, and it's not right for all projects, but like everything, it's important to know how it works, what it does, and why we do it in order to make sure that it's what you need or what you don't need for your project. So if this video helped you, or it could help someone you know, send it to them. And again, if you want to talk a lot more about this stuff, feel free to get a hold of me, because I can talk forever.